Vignan's deemed university, building Young India.
Hi everyone, welcome to my lecture series on energy audit, conservation and management. We are in our fourth unit, that is energy efficiency in electrical utilities. So in this unit consists of three modules. The first module is power factor improvement. The second module is energy efficient motors, and the third module is demand side management. So far we have successfully completed the first two modules, that is power factor improvement and energy efficient motor. Now let's discuss the last module, that is the third module of the unit 4, that is demand side management. So what is a demand side management? Demand side management is otherwise called demand side response, is the modification of consumer demand for energy through various methods such as financial incentives and behavioral change through education. So what is the major concern of this society? Energy. Nowadays the consumption of energy is very high. If the consumption of energy in the society is very high, the government have to build many power plants, and for that they have to invest crores and crores of rupees, right? So for that reason they have started a program called demand side management or demand side response. By means of operating this program, they can reduce the energy consumption in the society, or they may reduce the peak demand of the electrical supply. But how that can be achieved? That can be achieved through two things. The first thing is by providing financial incentives, and second one is behavioral change in the consumers through education. By means of these two initiatives, the government wants to reduce the peak demand as well as the total energy consumption in the society. Now let's discuss in detail about demand side management. At this point there may be some doubt regarding what is demand side management, but once we move on you will clearly understand what this means. So the term demand side management is used to refer to a group of actions designed to effectively manage a consumer's energy consumption with the aim of cutting the cost incurred for supply of electrical energy, grid charges and general system charges. So what is the main aim of this demand side management? It is simple. You need to reduce the or manage the consumer's energy consumption. If you can able to manage this consumer's energy consumption, the government can benefit a lot in the form of reduced cost of supplying the electrical energy. That is, there is no need to build extra power plants, and there is no need to incorporate more number of grids, and there is no need to incorporate system charges for these grids and power plants. All these costs the government can save if they can able to manage the consumer's energy consumption by providing some group of actions or by doing some group of actions, and those group of actions are termed as the demand side management techniques. And let's see them in a couple of minutes. What are these different demand side management techniques? So the demand side management aims on using power saving technologies, electricity tariffs, momentary incentives and government policies to mitigate the peak load demand instead of enlarging the generating capacity or reinforcing the transmission and distribution network. The sentence says it all about the demand side management. So what? In a day you have a peak load at a particular time. Say for example, for a city, in order to power that city you have 4 power plants, and the capacity of each power plant is 100 megawatt, and thereby from 4 power plants you are getting 400 megawatts to power a city or a region. Now to power that region you have 400 megawatts of electrical energy produced from 4 different plants. Now for a particular time of a day, for 1 hour, maybe take an example of afternoon 12 to 2, this 2 hours, the peak demand for the electricity is more than the 400 megawatt, that is it will be 500 megawatt. You can supply only 400 megawatt to the consumers, But the consumers require how much amount of megawatt? 500 megawatt for 2 hours in a day. Only for 2 hours in a day they require 500 megawatts. In the remaining 22 hours they require less than 400 megawatts only. Now for that there will be two options. The first option is to build one more power plant of 100 megawatt capacity. Fine. It is the first thing. And the second thing is you manage the energy consumption at that particular 2 hours period, so that the power consumption at that period will be reduced to 400 megawatt from 500 megawatt, so that there is no need to install one more power plant of 100 megawatt capacity, because the government has to put some amount in order to install a 100 megawatt power plant. So instead of that, it will work on demand side management techniques, and this demand side management will reduce that 500 megawatt peak load to 400 megawatt peak load, and that will be sufficient by these 4 power plants of 400 megawatt total capacity to supply this load. So instead of putting one more power plant of 100 megawatt capacity, by using demand side management techniques, the government is reducing the peak demand to 400 megawatts from 500 megawatts. Doing so, the existing 4 power plants are sufficient to power this peak load for 24 hours. Right. It is what is called demand side management. But how this demand side management will be performed? And this demand side management is nothing but a group of actions, and those actions include using power saving technologies is one action, and electricity tariffs is one more option. Momentary incentives, by providing incentives, it's the third option, and the government policies is the fourth option. By doing all these actions together or individually, you can reduce the maximum demand occurring on a region to suit your power generation capacity, so that the government can get a savings in terms of reduced cost, because there is no need to put some amount towards constructing a new power plant as well as transmission and distribution networks. Right? Now let us see the demand side management techniques. There are 6 demand side management techniques which are used by the governments to reduce the peak demand for that particular period. They are peak clipping, load shifting, strategic growth, valley filling, strategic conservation, and flexible load shift. By implementing these 6 actions, the governments can able to reduce the peak demand to required level. How? And what are these techniques? Let's see one by one. The first one is a load shifting, right? The figure itself is self-explanatory. What is that? The load shifting technique essentially moves electricity consumption from one time period to another time period by shifting loads from peak period to off peak period. What is the meaning of it? We have seen that from the graph you can clearly see that the time of a day on the x-axis and load in kilowatts on the y-axis. Now you can see in the example which we have stated in the earlier, which we have stated a prior, what is this? The maximum capacity of that power plants is 400 megawatt. If the peak period, so during the peak period, the demand is 500 megawatt now, or more than 400 megawatt, maybe 450 megawatt or 470 megawatt or 500 megawatt. But you have a capacity of 400 megawatts alone. Now what you have to do? The remaining 22 hours are off peak periods, where the power is being consumed less than 400 megawatts only, even less than 100 megawatts sometimes, or even less than 200 megawatts sometimes. So what you have to do? You have to convince the people or the consumers so that they can shift their peak period load consumption to off peak periods. Say for example, during the 12 to 2 time in a day, you are getting a peak load of 450 megawatts, but the system will be capable of giving you only 400 megawatts. So you have to shift this 50 megawatt to off peak periods. For example, postponing an industrial process to another time. During that time, say some industries are operating. Now you can convince them to shift that shift to midnight, where there is a low power consumption or an off peak period. So if you can shift the industrial process from a peak period to the midnight, it is off peak period, then obviously that 50 megawatt can be reduced, and that existing 4 power plants is enough to power that region. So what is the advantage to the industry? So government will have an advantage. What is that advantage? There is no need to build one more power plant. But what is the advantage to the industry because of shifting its operation from peak period to off peak period? The idea is that by shifting the load to another time, the returns generated through energy cost savings are greater than the loss of production. Two things. The first one is, if industry didn't agree for this, then what happens? The existing power plants cannot supply that power, and automatically the complete power in the region will be shut down. So the industry, because of lack of production, will lose a lot of money. It is the first concern for the industry. And second advantage to the industry is, by shifting its operation from peak period to off peak period, the government will give you some incentive. Say for example, previously the cost of electricity is 10 rupees per kilowatt hour, which we have already seen. Now government will give an incentive that when you shift your power to off peak period, we will reduce the cost per kilowatt hour consumption of your electricity to 6 rupees instead of 10 rupees. Then automatically the industry will get savings in terms of energy cost, and that is the reason why industry will readily accept to change it to off peak period to from peak period. So this is how the load shifting will be performed. So the net effect of this load shifting is a decrease in peak demand. So obviously there is a decrease in the peak demand, but no change in total energy demand, right? That 50 megawatt, they are not reducing it, they are reducing the peak demand at that 2 hours, but that 50 megawatt will be added to the remaining hours, and thereby there is no change in the total energy demand, but you can decrease the peak energy demand at that particular peak period. So this is what is called load shifting demand side management technique. And the second one is peak clipping. So during this peak period, that is, if the power plants can supply 400 megawatt, but the peak period consumption is 450 megawatt or 500 megawatt. So during this peak period, most generator units generates close to the capacity limit. Each and every power plant has to generate 100 megawatts. Then only they can supply the load. Even that is not enough to supply the load sometimes. So the electrical system, because of this overloading, becomes highly stressed, and the reliability of the whole system is reduced, or you can say damaged. What is reliability means? Fault tolerant nature is reduced or collapsed. Now because of this, the system becomes more vulnerable to failure, and the probability for the loss of load increases. So if it continues, if the load is 450 megawatt and your supply is 400 megawatts, after some time your power plants cannot supply this, and because of this there is a complete failure in the system, and there won't be any power available to the complete region, and the complete region will be in darkness because of the failure of the grid. Now we have to employ a method called peak clipping. So this peak clipping demand side management technique is a direct load control technique that aims at peak reduction of consumers' load profile at a specific period. So what we have to do? We have to directly control the loads of the consumers in that particular region, right, by the government or the power plant officials itself. And this can be done by direct control on consumers' appliances at the time of peak load or through time of day tariff. There are two ways to reduce this peak demand. The first way is, you have to directly control the consumers' appliances, whether they will be in operation or not. You manually cut down 50 megawatt from the system by yourself. So for that 50 megawatt, you will mercilessly cut down from the region. That means if an industry is operating, it will lose its money because of no power available to them, because you are cutting down 50 megawatts intentionally or mercilessly. Or the other one is encouraging people to cut down their demand by means of a incentive, that is called time of day tariff. The load shifting is the thing which is used for the industrial consumers, whereas for the residential consumers, peak clipping is the technique. All the industrial consumers will be controlled through load shifting technique, but the residential consumers will be controlled or managed by means of the process called peak clipping. They will do two things. One is they mercilessly cut down the power in your homes for that particular 2 hours, or they will ask you to reduce your power through time of delay tariff. That is called an incentive. Government will provide you an incentive. Accordingly, you definitely will reduce your, and that incentive will be encouraging you to reduce your demand. So the net effect of this peak clipping demand side management technique is reduction in both peak demand and total energy demand. How you will do it? Now let's see the time of day tariff. Now what is this time of day tariff? The time of day tariff is a tariff structure in which different rates are applicable for use of electricity at different times of a day. That is, the cost of 1 unit of electricity will be different during peak periods as well as during non-peak periods. So during peak period you will be having one cost, and during non-peak period you will be having some other cost. You can see it here. The cost of electricity will be more during the peak period, whereas the cost of electricity is less during the off-peak period. If you use more electricity during the off-peak period, the electricity price is less. If you use more electricity during the peak period, the electricity price is more per kilowatt hour. Let's take the example of a time of day tariff in a city of India, that is the capital city of India, New Delhi. So in New Delhi, it is the thing which is a time of day tariff. So we can see load type 10 to 100 kilowatt. So the consumers which are using 10 to 100 kilowatts, if he is a commercial consumer, what is the cost in the normal circumstances? 8.5 rupees per kilowatt hour. If he uses the same load during the peak period, the cost is 10.2 rupees per kilowatt hour. If he uses the electricity during the off peak period, the cost is 6.38 kilowatt hour only. That is, normally cost is 8.5 kilowatt hour. It's a normal base fare. Now government is giving some incentive as well as a punishment. What is that? The punishment is, if you use the commercial power during the peak period, you need to pay per unit 10.2 rupees. On the other hand, if you use the power during off peak period, you have to pay an incentive. You will get an incentive and you have to pay only 6.38 rupees. And likewise, if you are a LT customer, that is more than 100 kilowatt, then normal is 9.95 rupees per kilowatt hour and peak is 11.94 and off peak is 7.46 rupees. If you are a HT consumer, then normally you have to pay 8.4 rupees. But during the peak time you will pay 10.08 rupees and during the off peak time you will pay 6.3 rupees. It is for the commercial sector. The same 10 to 100 kilowatt load type, if it is an industrial sector, normally you have to pay 7.9 rupees, but during the peak time you need to pay 9.48 rupees. During the off peak time, if you use it, you have to pay only 5.93 rupees per kilowatt hour. If you are a LT customer, the normal payment is 9.95 rupees, but if you use it during the peak period, it will be 11.9 rupees. If you use it during the off peak period, the cost you need to pay is only 7.13 rupees per kilowatt. If you are a HT consumer and you are operating in the industrial area, your normal tariff is 7.4 rupees per kilowatt hour. But if you are operating in peak period, you have to pay 8.88 rupees. Whereas if you are operating in off peak period, you have to pay just 5.55 rupees per kilowatt hour. In this way, the customers or the consumers are encouraged to reduce their demand by themselves. In load shifting, government will ask an industry to reduce its load so that they will give an incentive to that industry itself. Whereas in case of a peak clipping, the government will provide time of day tariff, and because of this tariff is available to all the people, be it be residential, be it be commercial, or be it be industrial. Generally the residential loads are very less, but commercial industrial loads are very high. Industrial loads are factories. What are commercial loads? Like Vignan University is a commercial load, cinema theatres are the commercial load, multiplexes are the commercial loads, right? For all these commercial and industrial people, you are encouraged to reduce your power consumption during the peak period, because government is providing incentive if you use the power during off peak period instead of peak period. That is, during the peak period, instead of depending upon the government supply, you can choose your own supply like solar power or diesel power stations, or the DC sets in your campus, or the diesel generators in your campus will be utilized, and thereby your cost will be reduced, right? Now let's see the third demand side management technique, that is strategic conservation. The statistic conservation technique is used to achieve load shape optimization through application of demand reduction methods at consumer premises. Although this may have a long-term effect on network planning and operation, this technique will not be happening overnight. It's a long time process which requires some network planning and operation. So the statistic conservation is the load shape change that occurs from various targeted conservation activities like more efficient devices and appliances. You can see the diagram here. It's clearly stated that during the peak period it is 500 megawatts, which is represented by white curve, but actual capacity is 400 megawatt. So you have to reduce that 500 megawatts to 400 megawatt, that is the blue curve. But how can you do that? By using the energy efficient devices in your homes. This complete unit is meant for it, or this complete energy audit, conservation and management is meant for energy efficiency, right? By using cogeneration, trigeneration and waste heat recovery, you can improve the energy efficiency. By using energy efficient lighting, you can improve the energy efficiency. By using power factor correction equipment, you can improve the energy efficiency. By using energy efficient motors, you can improve the energy efficiency. By doing all these things, you could able to reduce the energy consumption. That is, you have to increase the energy efficiency of the equipments which are used in the system or the society, so that the power consumption gradually reduces over a period of time. It's not a overnight task. It requires a lot of attention and plan. So the net effect of this statistic conservation demand side management technique is a reduction in both peak demand as well as total energy demand, right? In peak clipping also, you are getting reduction in both peak demand as well as total energy demand by providing some incentive to the people, and thereby the people will get motivated to consume less power. Obviously the total energy demand as well as the peak demand will be reduced. In this case, without paying any money, the government have to introduce some energy efficient measures in the society, like star labeling. You already know that when you are purchasing any equipment, you are purchasing the star label equipments. Bureau of Energy Efficiency star rating. Will you purchase a 2-star rating or a 5-star rating devices? If you want to consume your electricity at a lower side, you need to consume 5-star rating equipment. Say for example, if you buy a normal refrigerator which is having 2-star rating, it will give you or it will consume 40 units of power every month. But if you take the inverter rating, the inverter technology 5-star rating refrigerators, even though they are at a very high price, but they will consume only 10 to 15 kilowatt hour per month. So in that way, you are able to reduce the complete power consumption in the society. Thereby, you can avoid the use of or building one more power plant to meet the peak demand. It is all about the statistic conservation. And the fourth technique is valley filling. What is this valley filling? Valley filling is a form of load management technique that increases or builds off-peak loads. That is, the load shape objective is desirable if the utility has surplus capacity in the off-peak hours. So this valley filling load shape objective is desirable if the utility has a surplus capacity in the off-peak hours. So during the off-peak hours, as you can see in the figure over here, during the off-peak hours, the power consumption is very less. Even though the power plants are supplying 400 megawatt, but the power consumed by in that region is only 100 or 200 megawatts. So 200 megawatts is still there. So how to fill that gap? Because the energy you cannot save it. Whatever the energy you have generated, you have to use it at a particular time. You cannot save that energy because it is a AC electricity. You cannot store the AC electricity. There are no devices available to store the AC electricity as of now in the market. So what you have to do? So this can be achieved through direct load control, right? So you have to encourage the people to use this opportunity by decreasing the time of day tariff. Then people will try to use during that particular time. Otherwise, they can shift from peak periods to off-peak periods so that the valley will be fit. The net effect is an increment in total energy demand, but no change in peak demand. Because you are operating in the valley filling technique now, peak demand is constant. There is no change in peak demand. But by adding the more amount of load during the valley periods, obviously you are increasing the total energy demand in the society. You are encouraged to consume more amount of electricity during that particular time by providing less tariff. And the next one is statistic load growth. What is this? So the load building technique is based on increasing the market share of the loads supported by energy conservation and storage systems or distributed energy resources. The net effect because of this statistic load growth is an increase in both peak demand as well as the total energy consumption. This is usually implemented by increasing the energy intensity and there are the addition of new customers. Say for example, you have this area, there is a particular problem, you have an area where the area is having 4 power plants and it can capable of giving you 400 megawatt of energy. But the peak demand at any time of a day is only 300 megawatt. 100 megawatt is kept idle for the entire year. Now what you have to do? You have to build your customers, right? So you have to start building your customers. That's a statistic load growth. So load building technique is based on increasing the market share of loads supported by energy conversion and storage systems or distributed energy resources. What do you mean by this? Energy storage systems means because there is a peak demand, you can encourage all these systems so that they will consume the extra energy and thereby the 300 megawatt blue curve will be shifted to 400 megawatt curve. So that 100 megawatt which is kept idle can also be kept in operation to supply this load. And this can be implemented by increasing the energy intensity. Means what? Energy intensity means what is the total amount of electricity consumed per person. By increasing the energy consumption per person, you can able to achieve this. Previously, if I am consuming 10 kilowatt hour per day per person by me alone, now I can able to, the government have to do some measures so that I can improve my energy consumption capacity to 20 kilowatt hour per day. Or you need to add some new customers to the region. You need to start some new industries, offers incentive to the companies so that the companies will come and start their operations and thereby they can use your electricity and thereby you will get your perfect statistic growth load curve, right? It is about the fifth technique, that is the statistic load growth. And the final technique is flexible load shape. What is this? The flexible load technique offers reliability to the smart grid by identifying customers with flexible loads who are willing to be controlled during critical periods in exchange for various incentives. So the government have to identify some consumers who can work at any point of time in a day so that when there is a off-peak period, so that the industries can operate either during peak period or during off-peak period depending upon the requirement. When the government asks you to operate in peak period, the industry should be ready to operate in peak period. If the government asks after some time to stop your production, the industry should be able to be in a position to stop the production. And if the government again asks to start the production during the off-peak period, the industry should be ready to start the production during the off-peak period. And those kind of flexible industries you need to identify in that region. By providing some incentives, they can be able to flexibly change their operating schedules. The flexible load shape refer to variations in reliability and quality of service. So instead of influencing load shape on permanent basis, the utility has an option to interrupt loads when necessary. So whenever there is a necessary, then that region supervisor can ask that industry to shut down that industry. They will do it, and they again the region manager will inform that industry to operate now. Off peak period is gone. Now once the industry operate during the off peak period, they will get a suitable incentive, and some industries will be ready for that. And you need to choose those industries. Not all industries will be agreeing for this interrupting power supply, but some industries which are very small scale or some flexible industries will easily agree for it, for getting the monetary benefits. And that is how you have to control the peak demand on the total energy demand of your region. So there may be a net reduction in peak demand and little if any changes in total energy consumption. Obviously there won't be much change in the total energy consumption because of this flexible load shape, because they are not operating at one particular time, but they are operating in the other particular time, and thereby almost the energy consumption is constant, but peak load you can able to reduce. It is one more alternative. Alright, demand side management technique. Right. So far we have discussed 6 demand side management techniques. So we have discussed the statistic energy conservation. By doing so, by implementing this technique, you can reduce the peak demand as well as the energy demand of that region. By implementing the peak clipping technique, you could able to reduce both the peak demand as well as the energy demand of that region. And the next technique is load shifting. By incorporating or by implementing these load shifting techniques, you can only reduce the peak demand, but you cannot reduce the or otherwise there is no change in the energy demand of the society or the region. And the fourth one is a flexible load shape, and this flexible, because of this flexible load shape technique implementation in the region, there might be definitely reduction in the peak demand, but the total energy demand may reduce or may not reduce. A little change only will be there. And the fifth one is a statistic load growth. By incorporating this technique, you are able to increase both the peak demand as well as the energy demand of that region. And valley filling, by incorporating or by implementing this technique in the region, you can observe only change in the energy demand. The energy demand will increase, but there is no change in the peak demand, because this is the only technique where you are not bothering about your peak demand, you are bothering about your off peak period energy consumption increase, and that's why your energy demand will increase, whereas the peak demand there is no change. All these are the list of different demand side management or demand side response strategies. So we have completed, so we have come to an end of this fourth unit, that is energy efficiency in electrical appliances. So as we have already discussed, this module, this unit number 4 consists of 3 modules. The first module is power factor improvement, the second module is energy efficient motors, and the third module is demand side management. So in the first module, that is the power factor improvement, we have seen what is a power factor, what are the causes of low power factor, and why we need to correct this power factor, and we have already seen the analysis, different analysis of power factors in terms of lace packet and cappuccino. And later we have seen different power factor improvement equipments, and what are those? Static capacitors, synchronous condensers, and phase advancers. And then we have gone through the most economical power factor. Then we have gone through some tutorial problems on this most economical power factor. Fine. And in the second module, it is the energy efficient motors module. We have seen what is an electric motor, what is a motor efficiency, and what are the different losses that are encountered in electrical motors, and how you can reduce those losses to improve the energy efficiency. So the energy efficient motors are obtained from the standard conventional motors by performing 2 things. One is improvements as well as the utilization of high energy efficient material or high quality material. So we have seen for different losses, different energy efficiency improvements, right? And we have seen 2 important things here, that is the efficiency of an energy efficient motor is always 4 to 6% more than that of a standard motor. And one more observation we have observed here is, what irrespective of the loading, the efficiency of the energy efficient motor will be always more than that of the conventional motors. And the last observation that we have observed in this particular module is the energy efficient motors are more sensible to loading. The efficiency will be reduced if you operate the conventional motor below 60% of its rated load. But in case of energy efficient motors, the efficiency will reduce drastically if you operate them below 50% itself. But irrespective of the type of loading, the efficiency of energy efficient motor will be always more than that of the standard motor. And then we have gone through our third module, that is the demand side management. In this module, we have seen what is demand side management, and then we have seen different demand side management techniques. What are those? Peak clipping, load shifting, statistic load growth, statistic energy conservation, valley filling, etc., etc. We have gone through all these demand side management techniques. So with this, we have completed our 4th unit in all the respects. In the next video, let's start our 5th unit, that is energy efficiency in HVAC equipment. What is HVAC? Heating, ventilation and air conditioning equipments. Thank you.